Hello everyone and welcome back to Stationeers. Right, let me quickly take a look at this. So we have the tablet and well, I think daylight is approaching quite fast. So these guys should be shut off by the digital valve any second now, which will lower the overall volume of this system, which will make the filling a lot faster. Now, I also want to change the way the safety system works for the radiators, and for that we will need at least one more pipe analyzer. I think we can safely leave this to fill, so I will very quickly go home, pick up a pipe analyzer and install it real quick. Well, basically what I want to achieve is that I want to have the digital valve turn on, not based on the outside temperature, but whether or not the inside temperature of the pipes is higher than the outside temperature. If we can do at least a tiny bit of radiating, I want to do so. For example, if we have, I don't know, 200 degrees Celsius stuff in the pipes or in the radiators, then I want to turn on the digital valve once the outside temperature is 200 degrees or lower. So I think that's going to be a little bit better that way. Anyways, for that one we need this guy and a pipe analyzer, iron gold electrum. So you guys empty out. Electrum, I believe it's iron and gold, right? You, and give me one of these. I think we can move up the condensation valve by 1 or the digital valve by 1, and that should give us enough space to install this. Also, the suit is fine, not great, but it will survive. We have one more waste tank, so we can manage. Right, I think I will move up the the digital valve. Also, it turned off. The outside temperature is too high, so that is encouraging. But first, we need to pick up a piece of regular piping, so we can put in that extra. There, you come with us. And how is the filling doing these days? It is... yeah, exactly. The digital valve is shut off, so now this one is filling a lot faster, which means we have condensation, and this one is cooling slowly. Also, I do believe we started the cooling process at 136 degrees in the base, and now it is down to 133. Nice. So the cooling is working. It will take a long time to ramp up because we need to cool this one down, and that means that we need to keep this one cold as well. So yeah, it's going to take a while, but as soon as the base is down to temperature, then it's going to be a lot more efficient. Okay, I think for now I will turn this guy off. I will leave this one on and we can put any condensation into the system, but for now let's take care of that extra safety system and do it now because we are not using the digital valve at daytime. So we need to pick up one of the one of the insulated pipes right here. Good. Move up the digital valve. So you will need to be moved up by 1. That way. There. And we need to put in one of these regular pipes, and the analyzer will go there. Okay, waste tank caution, switch it out. So digital, the pipe analyzer can go right here, turn on and quickly hook up the power for the valve. Quick before we run out of something. And that will do. Okay. We can go inside and we need to reset the code. Okay, temperature-wise, we should be better off. Oh, and now we are 132, so yeah, the base is cooling, but we have a lot of volume to cool, so don't get too excited. This will take a while. Next up, yeah, I know, error in the code, but that's fine. Laptop out, open, you come out, just shut off for a second, import, edit, and pause. We need one more device. Alias, that is going to be the analyzer. So, analyzer, that's going to be device 2. And then we need, and this is going to be the outside temp from now on. And then we also need alias, a radiator temp. That's going to be R1 and this is going to be R2. So outside temp, load both of them here. Load the radiator temp from the analyzer. That will do. And we need to make sure that we only turn on the valve. So this is not going to be true anymore. We need to make a check. So set if, let's say, less than, right? No, greater than. So GT. So on off needs to be changed on off if the outside temp is greater than the radiator temp, right? So set greater than, no, other way around. If the temperature in the radiator is higher than the outside temperature, then we can enable the valve. If the outside temperature is higher than the one in the radiator, then shut off the valve. Right, this one should work. If not, then we will change the stuff around, but as far as I can tell, this one should be okay. So export, you go in there, and then we need the screwdriver, and so gas sensor, initialize this for a second. So gas sensor is fine. Double check, that's fine. Then this one needs to be the digital valve. Need to reset digital valve, that's supposed to be okay. And then we need the pipe analyzer. There we go. So you should be having the valve to be off right now. Let's take a look. I suppose we can check on this one. 87 is not going up, and the temperature in this one is, yeah, way higher. So yeah, the valve is right now off. Good. But as soon as this one drops below 187, then the valve should turn on, at least theoretically. So hopefully that's going to work. Good. So how is the filling going? Also, now we are back up to 133. Not the end of the world. We just need to make sure that, you know, we don't overheat this one. 52, 52, yeah, it is equalized, but as soon as this one is down in temperature, then we should be back to normal. By the way, this one is 18 megapascals. Yeah, I think this one is going to be okay. Right, so we are not filling this one anymore. What is the pressure in here? Yeah, let's just vent it out. Yeah, you can turn off, just vent out. I don't want to have any condensation right now. I will deal with the filling as we need in the future. For now, let's just pump this one down to, I don't know. I suppose at this point we can turn it off. But you know what, no, just empty it out completely, just to be extra safe. Basically anything below 5-ish megapascals should be safe. Yeah, that will do. Okay, you can turn off now. Right. Ooh, and the base temperature is rising. Not surprising. This is a bit of a problem. Ooh, is rising actually quite a lot. Okay, the temperature in the radiators is dropping. It will eventually equalize and that's going to be fine. So, let me see. I think now we can start setting up the monitoring station. Okay, what do we need? We need pipe analyzers first. So we need 2 liquid pipe analyzers and 3. Let me see, 1, 2, 3, 4 pipe analyzers for the condensation chambers and the exhaust. And maybe, yeah, we can read the pipe analyzer for the radiators right there. So yeah, 2 liquid and 4 normal pipe analyzers. But first, we need to install a little bit of extra piping, at least on the exhaust. So we need to install a pipe analyzer for this one. You will go right here and the analyzer will be here. And the same for this one. There. We can install the analyzer for this condensation pipe here. And for this one here. Right, also, before I forget, we will also need to have data and power for the console. So, cable cutters, you will be here and here. There, and we can put the analyzer there. So we will also need one more cable there. Right. Okay then, yeah. So what is the situation with the temperatures now? This one is very good, it is dropping, which means that it will start condensing around 150-ish degrees Celsius, right? Which means we might want to, yeah, we need to put in a bit more. Now that we have equalized with the radiators, the pressure dropped, so we need to put in a bit more. So vent in, you turn on to keep it safe and keep the good gases only, and there we go. So you are dropping the liquids in. This one I think is going to be okay. Also, yeah, the base is cooling again, slowly. Anyways, let's go ahead and bring in those analyzers next. And eat and drink, obviously. By the way, I do believe I did turn off the water generator during the night, which can be a bit dangerous for the radiators. I want to check also. Ooh, power is going up in the base, very nice. I want to check that nothing bursts. I think it's safe to turn this place off during the day. I'm not sure about during the night. Okay, so far it looks okay. I am just a bit paranoid about the radiator. So you... Okay, we don't have a lot of pressure in this one, so it's fine. Right, okay, I think this is safe now. I don't remember when I was shutting off the power for it, so I wanted to double check. Anyways, suit, vent, switch out the oxygen, and we can strip down. Right, so we need 2 liquid and 4 gas pipe analyzers. So analyzer, 2 liquid and 4 gas. By the way, what is the oxygen situation these days? Ooh, 177, nice. Anyways, that's one, that's another one, and then pipe analyzers, 4 of these. Good, what else? Should we install a couple of extra wind turbines? We might want to. I think unlike the AC units, these will have a continuous power draw, so I am not sure. if you want to install a couple of extra. By the way, that is only 3, we need one more. Then we will need at least one IC housing and one IC10 chip. And then, yeah, and then we can start setting things up. So first things first, I don't know. First, eat and drink. We definitely need to have the chip and the housing, so that's okay. We can print those out. So you close and turn off. So give me one housing. Copper, steel, solder. So solder, steel. Then I believe we'll need gold and electrum and other kind of stuff for the chip itself. Copper. And copper is starting to run low again. Anyways, I'd say 10 housing. Good. You are finished. Now, I think once again I will write the code off camera. It's going to take a while to make sure everything works as intended. But so far I think we will be okay. So, housing. Yes, one chip please. And then we need to start printing out a lot of different displays and labels and maybe a couple of adjustment knobs, stuff like that. All right. Oh, we will need to monitor temperatures and liquid volumes and pressures and oh geez, a lot of stuff. So yeah, I think I will preemptively print out a couple of extra consoles, so modular consoles. This one we need silicon. I am fairly certain that we will need to have that vertical surface. I think the amount that we have on, okay, it's not going to be visible on that console is not going to be enough. We need a lot of readouts, so we might as well preemptively print them out. Also, do we need all of it? Let me see, for these vertical pieces, where are they? Yeah, these. I want to have this one. Okay, we need a single one, just that's it. Right, so this one will be right here, right on top of the big console. So we only need a single kit for this. You can turn off, and I will do these setups in between episodes. Don't worry about too much about it. It's going to take a lot of trial and error. So yeah, the suit is fine. Yeah, we can go. And the radiators should be on, and they are. Right. Good. So I think the safety system for the radiators is working as intended. Also, this one is starting to drain. That's not great. Hopefully we will have some sunlight relatively soon. Hopefully. It is now 7 days or 1 week after peak summer, so hopefully we will be in a better place from now on. Anyways, you guys can go here for now. The liquid pipe analyzers will go there. You can turn on, and you as well. Good. And then the gas pipe analyzers. This is for the exhaust. This is for this condensation chamber. Yeah, you can go that way. This is going to be for the condensation chamber of the base cooler, and the exhaust goes right there. Good. Now you just need to hook them up. Okay, so what is the pressure in this condensation chamber now? 10 megapascals, I think. Okay, yeah, I will stop right on 10. I think that should be okay. Yeah, the outside temperatures are, well, not great, but that's okay. Right, I think we can stop now. So you turn off. Yeah, I think we can stop now. Yeah, just vent out the excess. It's okay. Good. This one. Ooh, nice. The base is down to 130. Okay, 31, but it's getting there. But the temperature in here is only 71, so it is only a matter of time. Very, very good. If we hook up all these vents, then I think we can maybe speed up the heat exchange, because we will have, let me see, although I don't think it's going to help a lot. Well, whatever.
Storm incoming.
Ooh, storm incoming. Okay then, that's actually not great. It will be great for the power for the base, but it's not going to be good for the cooling. Anyways, it is actually good that we have low temperatures inside the evaporation chamber. So that can exchange with the base. 127, very nice. The base is cooling. I was thinking that maybe we should have another one set up on this side too. I will monitor the efficiency in the long term. If this is not enough, then we will install another one, it's fine. So this one is 12 megapascals, yeah, it's okay. You can turn off now, as you as well. So right now, we only have the devices that will actually serve the cooling. This one is off, this one is off, right. What is the situation with the power consumption? It is 785, right. We can lower this a little bit if we change the setting on these guys. So right now they are going full tilt, which means they are consuming 200 watts. Basically, we are sacrificing 20 watts for 1 liter of throughput on these volume pumps. All we need to do is make sure that if we lower this, we don't overpressurize the exhaust. Basically, don't go above 5 megapascals. As long as we don't, we can lower the throughput of these volume pumps, and that should allow us to lower the overall power consumption. 5 liters. Also, the radiators should be off now. Right, they are heating up, that's fine. So maybe a little bit more. We have 3 liters. That's only 60 instead of 200, so that's a big improvement in terms of power consumption. Although it's getting a little bit too close for condensation, so let's just go for 4 liters. So 80 instead of 200. Yeah, I think that's going to be a bit safer. I think we will automate this. So if the pressure in here is too much, then we'll increase the throughput, that kind of stuff. But for now, I think this will hold. We can do the same for this one. 800 kilopascals. We can go down a lot. 4 liters, let's see what we can achieve with that. I think that should be safe. Yeah, 286, 87. Yeah, I think it's holding. Good. Right. Ooh, and the base is cooling quite nicely now. Basically, now we are below the ambient nighttime temperatures. Very, very good. And the evaporation chamber is a lot colder than that, so we will cool the base quite nicely. Then, this one. Obviously, condensation heats it up, but It's not as bad as it was last night, so that's good news. Right.
Storm incoming.
Is this one 14 liters evaporating in here? I think at this point I can dismantle the filling pipes. It should be relatively safe. If not, then we will hook it up maybe from the back. Yeah, if we really have to, we can install the filling back here, is fine, but I think we can dismantle now and put in the console.
Storm.
Yeah, I keep turning it off, but the weather alarm system forces it to be on. Anyways, you can come up and you can go in the corner. I will leave this one because I am not sure about what is the amount of liquid in here.
Incoming.
Oh yeah, this one is a bit more filling. Yeah, I will leave that filling right there for now. Anyways, very slowly dismantle this pipe. We don't want to overpressurize, so one at a time. Yeah, exactly. Keep an eye on this.
Storm incoming.
Yeah, a bit more. Only want to pick up the rest of this this pipe basically once this one is safe. If you pick this one up now, it will definitely overpressurize, and that's not going to be great. By the way, what is the... do we have any damage? No, I don't think so. Right. So we only want to pick this one up if it is safe. Yeah, if it's down to 2 megapascals, we can pick it up. By the way, why is this emptying so slowly? What is the pressure on this one? Ooh, that's why. You know what? Let's just go for 5 liters on each, just to be on extra safe. Yeah, 5 liters. So that will lower the pressure in the exhaust, which should speed up the emptying of the liquid. Exactly, good. I think at this point it should be safe to pick this one up. 3 liters. Yeah, it will not double the pressure, so I think it's safe to pick this one up now. So you come up. He's not complaining. Good, okay.
Storm incoming.
Yeah. Let's pick this up. What kind of gases do we have in here? I think I emptied it out, but not completely. Let's take a look. Okay, never mind, it's empty. Okay, we can safely bring all this back. You go there, merge all these pipes. Good. And I will put these into the base cooling. There. Can we reach the next set of vents? Well, not all of them, but maybe at least one. Yeah, we can reach one of them. That's fine. I suppose we can pick up this side and hook up these as well, but you know what? It's fine. It's not really that important. Also, temperature inside the base, 121. For such a large volume, we are cooling a lot faster than I anticipated, so that is super good news. And the temperature in here is 102. Yeah, now it's increasing because we are losing heating efficiency. That's understandable. 606. Wow. 631 even. Okay, temperature in here is increasing quite a lot, but we are nowhere near the dangerous pressure, so it's fine. Oh, right, that's why. Now the temperature outside is dropping. Good, so we will start cooling in a second. Nice.
Storm incoming.
Yes, I know, I keep turning it off. I'm sorry. Anyways, now we have room for the console. So, modular console and modular console. We want to have the... Where is it? so many models, but that's what's great about this mod. So not this one, I want to have this one. Right, this is going to be the monitoring station, and then I want to have that vertical surface right on top. Yeah, that one. This should give us plenty of room. If this is too much, then I will just install a smaller one, that's fine. Let's see. We will need a lot of different monitoring, and maybe we can adjust the different knobs.
Hydration critical.
Although I think they are fine as they are. Maybe we can adjust the volume pumps. But for now, let's just go for the monitoring. So I will bring in, let me see, we will need at least pressure and temperature in here, so that's already 2. Then the same for this one, maybe even the volume of liquid in here, so that's at least 3. Then 3, that's already, let me see, 8, 10. In this one we just need temperature and pressure, so that's already 14 displays. Wow, that's going to be a lot. Then we want to monitor the pressure and temperature in here, maybe the liquid volumes, so that's already 6, so that's 18. That's going to be a lot, but well, that's part of the monitoring, I suppose. It's going to be a lot more space efficient than if we were doing it, you know, with vanilla LED displays. Also, what is this? The IC housing. Yeah, I will worry about that later. Also, did I put down the chip? I want to double check. I'm a bit paranoid. So the chip is... yeah, it's in the base. Okay. So we need to print out... okay, for now I will print out, let's say, 20 different labels. I will not print out the actual displays. I will do those later, at the very, very end. Also, the storm is here in 1 minute, so yeah, we got home just in time. So, for now, you, please give me a lot of labels. Yeah, label plates. Also, we can print out the labeler with the electric printer. Good to know. I thought it was only in the toolmaker. Oh well, anyways, we have one kit right here. Then we need at least 18, but I will print out 20. In fact, we will need a bunch of filler pieces as well, so I will print out maybe, I don't know, a bunch. Maybe 30 will be enough. I guess we will see. Also, the storm is here. Temperature outside is 276 or 77. Not too bad. And which direction is it blowing? It's blowing towards the base. So if we go out now, we should be able to reach the base relatively quickly. Anything else we need? Not really. Yeah, I think we can go. So the suit is, just in case, I will switch out the oxygen there, and we can go. Nice, we made it. Thankfully my muscle memory was enough to guide us to the base. So there's the chip. I think I will install the monitoring housing on here. Right, so you will be set there and hook up with the cables. So cable cutter, you will come out this way and hook into the system right there. Good. So how are things these days? The base is 121 degrees. The chamber is not quite all right. Yeah, we need a lot lower temperatures in here. Yeah, it's too high to condense thanks to the storm. Not much we can do about that, unfortunately, but oh, look at that, a full large battery. Thank you, storm. So for now, let's just put this guy in here. I will do the code later. For now, we will need a lot of these labels. So I guess I will divide the display in half. This side will be for the base cooling. This side will be for the cooling for the base cooling. So we will need, I suppose we might as well install two big labels on top like that. And then we can have a double divider right in the middle. Right, but first, let me see, labeler. This is the base cooling, and this is the, what do we call this one? Coolant cooling, whatever. Right, next up, I think I will move these guys in by a single step. That might be alright. So you will be here instead, and you will be there instead. Next up, we will need to monitor the evaporation chamber first. So let's just have a couple of small ones. Let's start with, I believe this LED displays can be 3 by 3 at most, right? Let me say modular console. Yeah, there we go. The displays. I am interested in the LED display 3. I believe that is 1 by 3, right? Or 1 by 4. I think it's 1 by 4 actually. So we want to have the nameplates 1 by 4 as well. So the condensation or the evaporation chamber, what do we need to monitor? The liquid volumes, the pressure, and the temperature, I think. Although the temperature, yes, the temperature as well. So we need at least 3 of them. So 1, 2, and right, we might want to, yeah, let's just have them here, it's fine. So that is the evaporation chamber. Then the exhaust is only pressure, I think. Temperature is not important for this one. So anyways, first things first, this is the evaporation chamber temperature. Then just copy this one. Then this is the pressure, and this is the amounts or liquid volume. Yeah, it's a little bit small, but it should be okay at a glance, I think. How is the temperature outside now? It is not great. Well, at least it is keeping at 250, so it's not too bad. Anyways, next up. So, the exhaust. Basically, that one will come out of the evaporation chamber. So, you know what? Let me quickly open the Windows character map. I want to copy the arrow characters. Can I find them real quick? Basically, can I create some kind of flow chart? So if I do this, no, it is not recognized. What about... Okay, that arrow is not recognized either, unfortunately. I wanted to create a... Or maybe we can use the exponent signal, exponent sign. Yeah, that will do, I think. So instead of using arrows, we will use these exponents to indicate which way the different flow is going. So, right, you can turn off. U will be the exhaust pressure. So, exhaust pressure. We have the display here. And then this one will go into the condensation chamber. Here we need to have temperature, pressure, and liquid amounts again.
Hunger critical.
So the same as this one. I suppose for this one we can set up a 1x2 turned this way. Right. Confirm. That looks good to me. Maybe we can add a single one for this one. Or how would it look like this? No, it's too much. Yeah, that's fine. So we will have the same exact readouts for the condensation chamber. So we will have 1x4, 1, 2, and 3. And then that will go into the liquid. Here we only really need to monitor the pressure. We don't need to worry about the liquid volumes or the temperature, so yeah, I think we can have a single readout for this one. But once again, we will have exponent sign indicating the flow direction. So once again, I don't know, let's just copy that one, it's fine. Copy over to this one. Good. And then once again, this one will go back into the evaporation chamber. So let's have a 1x2 going that way. So this is going to be the same as this one. Confirm. And there we go. So we have the condensation chamber. So liquid volume, copy, cancel. This is the condensation chamber. Copy all of it. And then this is going to be the pressure without just a single space, please. And this is going to be the temperature. Right, so I think this will look quite alright. Yeah. Also, how far are we from cooling the coolant? It is alright. Oh geez, 1080 degrees Celsius outside. At least this one is not increasing as fast, so it's fine. Right, let me see. Right, we just need to set up the same exact stuff on this side. Okay, we have already used up most of our labels, but I think we can manage. Okay, let's go for it. Oh, sorry, I didn't set this one. This one is supposed to be the the liquid tank pressure, right? Now it's all set up. I don't think I can make this one any smaller than this. Unless I use the small displays, but I want to have at least the displays to be relatively readable. So there is that. And right, we have 4 label plates left. Down here, can we fill this one up with anything? Because apparently this one is quite enough. I suppose we can set up some controls for the different purge valves and volume pumps and stuff like that. They are not going to be critically important, but something good to have. By the way, there we go, it is cooling. Good. And the base only went up a couple of degrees, so yeah, we are still below ambient nighttime temperature, so the base is slowly cooling. Right. And then we need all those displays, so let me check how many displays we need exactly. So 1, 2, 3, 4, 5, 6, 7, 8, 16 altogether.
Hydration critical.
Right. I suppose we can have the base temperature displayed here, maybe the outside temperature displayed here. That would be kind of nice, especially right in front of the elevator main entrance. So there is that. And then yeah, we can set up some controls for these valves around here. Yeah. Okay, then let me just quickly, maybe we can do one side. So we can have a control knob for the liquid storage purge valve, then one for the exhaust volume pump, one for the pressure in the evaporation chamber, and maybe we can turn off the evaporation chamber itself if we have to. In fact, I think, yeah, what we can do is set a small dial here to adjust, and then we can have an on-off switch if we have to. Then maybe we can have a master on-off switch right here in the middle somewhere. Yeah, I think this is coming along quite nicely. Right, anything else we want to control? Not really. Anyways, how is the cooling? So this one
Health low.
should start condensing out relatively soon. Yeah, it is dropping, which means it is equalizing. Yeah, unfortunately, I don't think... By the way, where is this one getting all that extra temperature during the day? Oh, right. It is getting it from here. We have a tiny bit of condensation, although, no, wait, that's not going to happen because we have too much temperature out there, so we shouldn't have any condensation. And the valve should never turn on if the outside temperature is higher than the inside. So I have no idea where that extra temperature is coming from. The condensation in here is nowhere near enough to go all the way up to 700 degrees. I will need to investigate this, but other than that, I think this is alright now. Now, obviously, I will fine-tune the layout as I'm doing the code, but, you know, one thing at a time. Okay, we can go home now. Power-wise, we are okay. I think we can leave the base as it is. Just one last check. It should start condensing out relatively soon. But I really need to investigate where that extra heat is coming from. It really shouldn't happen as far as I can tell. Let's just take a look at it from the outside. So we shouldn't have any condensation if the temperature outside is too high, even with the extra pressures. So even if we go above, I don't know, 50 megapascals, it should never really condense out with the kinds of the kind of temperatures that we can achieve. So it shouldn't be the liquid input. In fact, the liquid itself is 142, so that is definitely not the culprit. And this guy should never turn on, right? If the outside temperature is higher than the inside. So this one shouldn't be the source of the extra heat in the condensation valve chamber. But that is the only possible culprit. There is no other connection. Right. Okay, we need to take a look at that code. But first, go home, eat, drink, and then we can take a look at that code. Because I fear that I might have made a mistake. Maybe we have some kind of... Oh, nice. Base power looks healthy. Thanks to the storm. Maybe I left some kind of bug in the code that turns on the digital valve from time to time. I don't know. Anyways, let's take care of the suit, eat, drink, and then we'll take a look at that code. Okay then, so we are good to go on health. Let's take a look at this code again. Edit and pause. So we have the sensor, digital valve, analyzer set up, outside temperature, radiator temperature, and on-off. Theoretically, that is all we need. So at the start, load the outside temperature and the radiator temperatures. Those will be overwritten right at the start. Then we will compare them. And if the radiator temperature is higher than the outside temperature... Oh, yeah, I'm dumb. Not radiator temperature, it is the condensation temperature. This is the radiator temperature, basically. Wait, oh, right, I know. Right, we need to have the analyzer on the inside, not the outside. That's the problem. Okay, I figured it out. So, not radiator temperature, this is the... what's it called? Condensator temperature. So that... and that... and we just need to move the analyzer above the digital valve. So this is going to be the radiator temperature, basically. In fact, if we want to be extra precise about this, we should have one more pipe analyzer, and we don't need to have the sensor. Yeah, I think that is going to be a little bit better. So this is going to be the radiator temperature. So copy this one there. So if the condensator is higher than the radiator, then we can turn on the valve. Right. Okay, so we just need one more pipe analyzer and that's it. And we can pick up the whatchamacallit, the sensor. So can you please give me another pipe analyzer? Analyzer for the pipe, iron, gold, electrum, iron, gold, and electrum. One more of these. Okay, I think this should fix it. Just to be on the safe side, I will switch out the jetpack because we need to be up there in a little bit longer than usual. So first things first, we need to pick up the sensor. The code should be okay now. At least fingers crossed. So you need to come up there. And we need to have the pipe analyzer here. So there, switch out that one. In fact, all of these guys can face this way instead. So there, yeah, let's just pick them up and place them with less cable management. Very good. Okay, we can go inside, and as usual, the battery is off in the lamp. That's fine. We can switch out the miner, I suppose. So let's go inside and double check the code. Also, right, we need to name the analyzers. We need to know which one is which. So this is the radiator analyzer, and this is the condenser analyzer. Right, now it should be okay. We need to know which is which, obviously. We still need to rename a couple of devices in the code, but other than that, I think it's alright. So, obviously pause, laptop out, open, chip goes in, okay, just there, import, edit, and pause. Right, so we need to have, the digital valve can be device 0, we will have the condenser analyzer, and we will have copy, paste, and we will have the radiator analyzer there, and then we will have the radiator temperature and the condenser temperature. Good. So we will load from the radiator analyzer the radiator temperature, and then the condenser temperature from the condenser analyzer there, and then turn the on-off to 1 if the condenser temp is higher than the radiator temp. So right, if the inside temperature is greater than the outside temperature, then we can turn on the valve. Right. Fingers crossed that this is now correct. Confirm, export, and you go right back. Initialize for a second so we can read the device pins. And then screwdriver out. So digital valve. We need to have the digital valve like that. Then we need the radiator analyzer, and we need to have the condenser analyzer, and that is going to be this one. So right now it should be off. Oh, sorry, on. It should be on. Also very nice, we are condensing, and as I said, it should be on. I will not break open the windows now, obviously. We don't want to lose any cooling that we have achieved. It is now 119 degrees inside. Nice. So it should be, the digital valve should be on because the inside is higher than the outside. But it is not on. Why? Double check. Edit and pause. So radiator, condenser. If the condenser is higher than the radiator, then turn. Oh, right, it's heating up outside now, that's why. Okay, it is actually correct. So it is daybreak, which means that the temperature in here is higher. Good, which means that this one, yeah, the condenser is 51, this one is 52. That appears to be correct. Right, okay, I think the bug is fixed. Okay, we can go home now. Right, so in the next episode, I will try to make sure that we have the code all good to go. And then I will print out the displays, whatever extra controls we need. And
Suit damage.
ouch. Okay, quick. Patch the suit. I bang my head on the landing craft. I wanted to avoid this, but oh well. It was bound to happen sooner or later. Yeah, sometimes this happens unfortunately, but not much we can do. Anyways, the suit is okay now. It's a bit damaged, but 17 OGs, that's a lot. I might print out another one and recycle this one, but we will worry about that later. For now, I think this episode is good to go. Yeah, I believe all that is left to say is that thank you for watching. If you liked the video, you can leave a like, leave a comment, and maybe subscribe to the channel if you want. If you would like to support me a little bit more, you can do so by clicking the join button and becoming a channel member, which will give you an early and ad-free access to these videos. Once again, thank you for watching and thank you very much for your support. I will see you in the next one. Thank you and goodbye.